right, so in this section, we're going to talk about translating expressions, right, into like verbal or algebraic form. So take a look at this one. Translate this into an algebraic expression. 3 times the difference of a number and 8, right? So 3 times the difference, that means subtraction, right? The difference of what though? A number and 8. So that's going to be x minus 8. When you have the difference, it has to be in the same order that the items are given, right? X and then 8. Okay, so next, translate this into a verbal expression. So basically, this will be a number p cubed. And then you can say like plus or added to 4 times. Now, it's p again, right? So to say that you're going to use the same number, you literally say 4 times the same number. Okay? All right. This one is an equation. Yeah.
For questions like is there only one right answer?
No, there can be more than one, but it has to say like, you know what? Yeah. Okay. So this one. So here we have 2c, right? So you can say, for example, twice a number c. And then you have an equal sign. We can say is the same as okay, so again, it's the same number, right? So we said twice the number c is the same as, we can say the number, right? That means the same number. So the number squared minus 4. Okay? Yep.
Could you just say is the same as the difference?
The difference of the number squared and 4. Yeah. Okay. So let's solve a couple of equations, right? These are basically algebra 1 type equations. Here we're going to add 14.29. So x is 39.29. Here, we're going to multiply by what? 3 over 2, the reciprocal. So y is negative 27, right? I mean, you can always reduce, so 1 and 9, so negative 27. Okay, here, I'm missing parentheses. First, I need to distribute the 3. So negative 10x plus 7.5x minus 6 equals 6. Adding this, negative 2.5x minus 6 equals 6. Add a 6 to both sides. Negative 2.5x is equal to 12. Now, on your quiz, you are not going to have a calculator. So all this needs to be done without a calculator. That means wherever possible, change decimals into improper fractions. So like this one. If you do 5 over 2x is equal to 12, now it's so much easier to work through this, right? So now x will be 24 over 5, which is just fine. We don't do mixed numbers. We don't do, I mean, you don't need decimals. We always prefer fractions to decimals, and then improper fractions as well. Mixed numbers are so like middle school, okay? Yep.
Why isn't it negative?
Oh, shoot, I forgot the negative. Sorry. It is negative. Thank you. Okay. Yep.
What do you get points off if you have it in decimal?
So if you had decimal, you were going to do 12 divided by 2.5, right? And that's going to waste a lot of time. And you're not going to be able to finish. So you have to work more efficiently than that. Because if instead of like 2.5, if it was like 7.5, and here you are trying to divide, then it's even more, right, difficult. So fractions are always more efficient. Okay, let's distribute this here. So 3 over 2 times 15d, we can put that over 1. That's going to be 45 over 2d plus 30. And then minus 1/6 times 18 is minus 3d. And then plus 2 equals 38. Okay. Let's add some like terms here. I have 45 over 2d minus 3d. So that's 45 over 2d minus 6 over 2d, right? So how much will that be? 39 over 2d. And then I also have plus 30 plus 2. Okay? All right, let's subtract. So I get 39 over 2d is equal to 6. And then we're going to multiply by the reciprocal. Times 2 over 39 times 2 over 39. Okay. So d is, we divide by 3, 6 over 13. Nope, 4 over 13. Sorry, guys. Okay? Right. And you know what? Sometimes we get improper fractions, right? Most of the time we get improper fractions because how often are we only dealing with integers? Right? Like if you go to the store and you buy a bag of apples and you weigh them, is it ever like 5.0 pounds exactly? No, never, right? And like if I, like how old are you?
15.
Okay, so is today your birthday? No. So you're technically not 15, you're 15 point, like, when was your birthday?
December.
Oh. Oh, like 15.9. Are you 15.9? Like maybe 8, 7, 8, 15.78, blah, 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 right? Right? So we are always dealing with non-integer numbers. So it's more natural that we get those, right? So don't freak out. Okay, take a look at this. So here I have parentheses. All right, I'm going to solve this for B1. Okay, now, first I need to get rid of the 2 and the h. Okay, so what if I multiply both sides by 2, correct? But then how do I get rid of the h? Divide by h. So I can just multiply by 2 over h then, right? So when I do that, what do I get? 2a over h is equal to b1 plus b2. Now, to solve for b1, I need to subtract b2. So let's subtract b2. Now, when we come here and we're going to subtract b2, we have 2a over h. All of that minus b2. That is equal to b1. Okay? So make sure you do that. Make sure you don't do like, you have like 2a over h. If you do minus b2 like this, that's wrong, right? If you do 2a over h minus b2 here, that's wrong. It's the whole thing minus b2. Yeah.
So when you do like you combine both the 2 and h, you'll have to do that.
Yeah. Yeah. Because half h, right? That would have been the same as h over 2. And then you would have multiplied by 2 over h. Okay? Yeah, you can do it in one step. Okay, here we're going to solve for y. So here we go. Solve for y means we're going to bring all the y's to the left and everything else to the other side. So first, why don't we... Hello. Hey, so your name is? Grant. Okay. Nice to see you, Grant.
Nice to see you too.
All right. Do you want to sit next to them?
Yeah.
Sure. Okay, for today, Okay, so this is Algebra 2 Honors. So where are you now? What school are you at now? Or has school started? Okay, what, nice. What math were you in last year? Okay, so what math are you in right now at Campbell Hall? AB? Okay, cool. That's awesome. Well, welcome. All right. All right. So minus 4x. But then I also need to get rid of the 6, right? So minus 6 minus 6. So I get negative 6y is equal to 2x minus 3y minus 4. Now, this is negative 6y. Now, I'm going to add 3y to both sides. So what I have now is negative 3y equals 2x minus 4. Okay, next, divide everything by negative 3. So I get y equals negative 2 over 3x plus 4 over 3. Okay? But also, from here, you could have just divided the whole thing. So you could have also said, this is 2x minus 4 over negative 3. That would have also worked. Okay? Okay, last one, and then we're going to go to the next lesson. So here, we need to solve for x, right? So we're going to cross multiply. Let's go ahead and do that. We'll put this over 1. So here, y times x minus 4 equals 2. Now, hey, right here. So if we're solving for x, I got to get y out of here, okay? So divide by y, okay? X minus 4 is equal to 2 over y. And then I'm going to add 4, so x equals 2 over y plus 4. Okay? All right. Next. We are doing 1.4 also. Okay. All right. So let's go to 1.4. Okay. In 1.4, we're going to solve absolute value equations, right? So now, let's talk about what absolute value is. If I see something like this, absolute value of 4, what that means is someone is asking, how far away is this number from 0 on a number line, right? So if I go on a number line, that number is 4 units away from 0. That's why this is 4. Now, if I say absolute value of negative 4, now I'm asking how far is negative 4 from 0? So how many units is that?
4.
4. That's why, right, that's 4 units. That's why absolute value of 4 and absolute value of negative 4 are 4. It's not that absolute value takes the sign away. Like absolute value has no such capabilities. It's just that absolute value asks for the distance between a number and 0. And since distance is always non-negative, that's how it looks. So now, thinking of it in a different way, if I told you absolute value of x is equal to 2, now I'm asking for all of the numbers x that are 2 units away from 0. What numbers are those? 2 and negative 2. That's why we say x equals 2 and negative 2, right? So now, looking at this, if you have, there are 3 situations. if you have an absolute value of whatever, x, okay, or it could be some other thing inside. So let's just do like a generic absolute value of something equal to a positive number, just like that red one, there are going to be two solutions. Okay? What if you have absolute value equal to 0? What if I said find all the numbers that the distance from them to 0 is 0? How many numbers are those? 1. It's just 0. So here there is one solution. And then if I have absolute value of something equal to a negative number, well, if absolute value is a distance, it can't be negative. So that's no solution. Okay? So now, if I have absolute value of something equals to 2, we said that equals -2 and +2. So if I have absolute value of something equals to 3, well, that means that is equal to -3 and +3. So here, this will be x minus 5, the inside, equal to -3 and +3. Okay, so now, in the first case we looked at, we just had x in the absolute value. So we're centered at 0. This one has x minus something else. So here, our center has shifted a little bit, right? So take a look here. The one we just did, this one, looks more like this, okay? So when you have that, x minus c equals a number, this is the central value. So what you do is x minus c equals to 0, solve for x, and that is your central value. Okay? And then the range is how far it goes. So for example, if I have, let's look at the top example. You know how we had x minus 5 is equal to 3? If I take x minus 5, the inside, set it equal to 0, x is 5, right? That is the central value, 5. And my range is 3. So from that, if I go 3 units over and 3 units over, what values do I land at? 8 and 2, right? So now, what do I get when I solve these equations? 8 and 2. Okay? So that's how that comes together. Okay, let's do this one. X plus 3 is equal to 6 in absolute value. So first what you're going to do is you're going to split these up. X plus 3 is equal to -6. X plus 3 is equal to 6. So now, x is -9. X is 3. Let's see that on a number line. Let's go to the original absolute value equation. If I have x plus 3 inside, let's solve it for x. I get -3. What's the range? 6. So I go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, where did I land? -9 and 3. Those are the exact same answers that we got, right? So that's what this is saying. All right? Okay, let's do another one. Here, okay, I know you guys are like catching up. Okay. Okay, so look here. Okay. Before we split this up, you have to isolate the absolute value, right? So let's get the absolute value alone. So we're going to add 1 I get 2. 2x minus 7 is equal to 4. Divide by 2. Absolute value of 2x minus 7 is equal to 2. Okay? Now, I have absolute value equals a number. I've isolated the absolute value. This is where I split up. So I say 2x minus 7 equals negative 2. 2x minus 7 equals positive 2. Okay, so let's solve this quickly. 2x equals 5. X is 5 over 2. 2x equals 9. X is 9 over 2. Okay, those are the two answers. Okay, let's see how that looks in a number line. We're going to take this, the one where we isolated. How do we find the central number? What do I set equal to 0? 2x minus 7. So x is 7 over 2. How much is 7 over 2? 3.5. 1, 2, 3.5. And the range is how much? 2. Look here. This is the range. Equals 2. So that's the range. So I go 1, 2. Okay. And then what else? 1, 2. Right? So those are the ranges. Okay? Yep.
So for the x equals, so
Yep.
we got 2.5 and 4.5. But
Yep.
the number line we got 5.5 and 1.5.
Okay. So I'm gonna come back to this tomorrow. Let's leave this here and I'm gonna come back to this next time. Okay? For now, what matters is not that. For now, what matters is the other stuff. Okay. Huh?
Question like this is going
You'll be fine on the homework.
in the quiz will be fine.
Yeah. Yes. Okay. So let's take a look at this. Here we need to isolate the absolute value, right? Okay, so look at what we're going to do. Divide by negative 2. So what do I get? Absolute value of 3a equals negative 3, right? What happens there? No solution. Okay? Okay.
For when we're saying no solution on the test, is there a specific way to like
You can either say that or say or write out no solution. Okay, next one. Okay. All of the ones that we did so far, you only had a variable inside the absolute value. Cool? Right now, we're going to have a variable inside and outside the absolute value. When that happens, sure, do you know where it is?
Do you want me to show you where it is?
He can find it. When that happens, okay, so when you have a variable inside and outside, you can run into solutions that don't necessarily work. So you have to go back and check. Now, the process to solve these is the same way as we have been doing. You isolate the absolute value. Once the absolute value is alone on one side, you say it equals to the negative of this and it equals to the positive of that. Same exact situation. All right? So in this case here, absolute value is alone. So I'm going to say 3x minus 1 is equal to negative x minus 7. And then 3x minus 1 is positive x minus 7. Now, let's solve this. 3x minus 1, negative x plus 7. So 4x minus 1 equals what? 7. 4x equals 8. X is 2. Here, 2x equals negative 6, right? X is negative 3. So now I have potentially two solutions, but I have to check. So let's go and check. Let's check x equals 2 first. To check, you have to put it in the original problem. That's where the problem would have occurred before you separate it. So let's see. When x is 2, we're going to get 3 times 2 minus 1. Is this equal to 2 minus 7? No. How do you know? Right. So here we're going to get 5 equal to negative 5. Okay, so no. So that doesn't work. Also, before I even did this, I know this is going to be negative 5. I can't have an absolute value equal to a negative 5, so already it was going to fail. Okay, now let's check negative 3. 3 times negative 3 minus 1. Is this equal to negative 3 minus 7? Well, here too, this is going to be negative 10. I can't have an absolute value equal to a negative 10. That doesn't work either. Oh my God, this is no solution. You can have both of them work. You can have one of them work. You can have none of them work. It all works. Okay, let's do this one. Yep.
So do you like to plug it back in when you have a variable outside?
Yes, when you have a variable inside and outside. Okay, this one. Is the absolute value alone on its side of the equation? Yeah, that means we can split. So let's split. Oh, hi. So 2x plus 5 equals negative of the other side. 2x plus 5 equals positive of the other side. Okay? So negative of the other side, positive of the other side. Okay, so now 2x plus 5. Okay, I'll race you to it. You ready? On your mark, get set, go. Let's do it. Ooh, okay, so look though. You see how I got 4.5x equals 3? What am I going to do here to make it more efficient? Fraction. Change it to a fraction. What's 4.5 these days? 9 over 2x equals 3. So I multiply by the reciprocal. It's so much more efficient. I love fractions so much more than decimals because decimals are hard to work with. 2/3 is right. I mean, it's an answer. We don't know if it's going to work. Okay, and then I'll do this one now. So what do we get here? We're going to subtract 2.5. So negative 0.5x plus 5 equals negative 8. Negative, I'm just going to write that as negative half x equals negative 13. So x is 26. Okay, let's check. Okay, so let's check the 2/3 first. Here we have absolute value 2 times 2/3 plus 5 equals to 5 over 2 times 2/3. So much easier to do that. Minus 8. Let's see if this is going to be true. Okay, 4 over 3 plus 5. What's this? 5 over 3 minus 8. Are these equal to each other? No. So first of all, like 5 over 3 is what? Like 2 something? Minus 8, that's going to be a negative number again, right? You can't have that equal to an absolute value, so that's going to fail. Okay, what about the other one? Oh man, I hope we get one that works soon. So let's see. 2 times 26 plus 5. Is this equal to, what is this? Oh, you know what? I'm going to do that here. Is this equal to 5 over 2 times 26 minus 8? Okay, let's see. That might have some potential, right? What do you guys think?
It has a lot of potential.
right? So what is this? What's 2 times 26?
52.
52 plus 5, 57. Here, 13. What's 13 times 5? 65 minus 8. Ooh, that works. Okay, that one works. First one so far, that worked, right? So now, when I'm grading a quiz or a test, the way in which you need to show your work, because, okay, so check it out. In higher level math, it's never about the final answer. It's always about the process. So when you do get to like the AP levels, it's always blah, 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 justify your answer, right? To justify your answer, you need to show the work. So it's the work that we are looking for. So if I were to give this problem, I need to see that you correctly did this. You correctly identified 2/3 and 26 as possible solutions. You checked both of them, and then you picked the correct one. If for this one you got 1/3 and 26, the 26 worked, the 1/3 still isn't going to work, you would get points off because your solution wasn't correct. Okay? I give partial credit. Okay? All right. So let's do this one. Okay. So 2x, the absolute value is alone, so we can split, equals negative x plus 3 in parentheses and positive x plus 3. Okay, I'll give you guys like half a minute to do this. Right, so x equals negative 1, x equals 3. Did we check any of them?
Yeah, they work.
Number 3 works. What about negative 1?
It doesn't work.
Are you sure?
Yeah.
You got
2 times negative 1 is equal to negative 1 plus 3. So this gives you a 2. And this gives you, oh my God, they both work. I know. It's like, it's a plot twist. You think it doesn't.
They will keep going. 'Cause I thought it didn't when we checked.
I thought it was positive.
Yeah, I thought it was positive.
Yeah, I thought.
Oh, it is negative 1.
I also thought it was positive.
2x equals negative x plus minus 3. It's minus 3, right?
Yeah.
So, yeah. Yeah? I know. Okay. Okay. The next one. Is the absolute value alone?
No.
No. So we have to isolate first. Cool? Let's go ahead and isolate first, then we can split. So when we isolate, what do we get? We get the absolute value 2x plus 1 is equal to 4x minus 4. X plus 1 in absolute value, 2x minus 2. Now I can split this. So x plus 1 is negative of 2x minus 2. X plus 1 is positive 2x minus 2. So let's see what we get here. Negative 2x plus 2. X equals 1/3, right? And here, x equals 3. Did I do those right? What do you think?
Yeah, you got it.
Got right? Okay, to check, look, we're gonna plug into here, the step right before we split it, right? So let's check. 1/3 plus 1. Is this equal to 2 times 1/3 minus 2? So here this is what? Does this work? This is 1 and 1/3.
No.
No, and this is just 1/3, so that doesn't work. What about 3? 4, that does work. So just 3. Right, so then Monday is your quiz on everything we've done so far. 1.1, 2, 3, and 4.